In this lab, you will perform SQL injections, a popular attack that targets web applications that use structured query language. SQL injections take advantage of security vulnerabilities and the web application's input validation mechanisms. Many web apps take user input through web forms or URL parameters. If the developers of the web app have not properly mitigated against SQL injections, threat actors can deliberately craft input that includes SQL code directly into the queries sent to the database. This is exactly what you will do in this lab. Part 1 is to perform SQL injections on the DVWA app running in your Kali VM. Log into your Kali VM. I already have mine open. Step 1 is to prepare the DVWA for SQL injection. Open Firefox and log in to DVWA at 10.6.6.13. Enter admin and password as your credentials and log in. Click DVWA Security in the left panel. Change the security level to low. Click Submit. Step 2 is to check if DVWA is vulnerable to SQL injections. Click SQL Injection in the left pane. Enter the following: single quote space or space 1 = 1 space hashtag. Let's look at what this does. In a typical login scenario, when the user clicks Submit, the application takes user values for username and password, incorporates them into an SQL query, such as this one, and executes it. For an injection attack, we replace username and its closing single quote with the following. This single quote denotes a string, and in this case is the beginning of the injected input. The OR is used to modify the original query's where clause. The 1 = 1 is a condition that always evaluates to true, and the hashtag ensures that everything that follows is commented out. The result is that the injection bypasses authentication and returns all the rows of the user's table. Click Submit to execute the injection. You can see that the injection was successful as it returned 5 usernames. Now that we know the database is vulnerable, in steps 3 through 7 we will gather information about the database and its structure. Step 3 is to check how many fields are in the query that is sent to the database when the user clicks Submit. We'll do this by entering another SQL injection. Highlight the injection in the lab and paste it into the user ID field. Let's look at what this does. For this injection, we replace username with the following. The 1 single quote finishes the where query and attempts to find a username with the value 1, which does not exist. The order by 1 is added as part of the injection to sort the results of the first column, and the hashtag ensures everything that follows is commented out. Click Submit to execute the injection. Because we get a response, we know the query has at least one field. Repeat the injection, replacing the second one with a 2, and click Submit. A successful response confirms that we have 2 fields in the query. Repeat, replacing the 2 for a 3, and click Submit. The unknown column 3 error confirms that our query only has 2 fields. As you will see later, this is the username and password fields as we saw in the first example. Step 4 is to check the database version. Copy the SQL injection from the lab, and then paste it into the user ID for the DVWA app. This injection does the following. The first part of the injection with the 1 single quote or 1 = 1 will return all the rows in the user's table. The union select 1, version adds a row to the output and returns the version of the database. Click Submit to execute the injection. Notice we get all the rows in the user's table plus the version of the database at the bottom of the output. For step 5, let's replace version with database to see if we can retrieve the name of the database. The last row of the output shows that the database name is DVWA. Step 6 is to attempt to retrieve all the table names in the DVWA database. To do this, we enter a rather complex SQL injection. I'm going to copy it from the lab. Let's take a look at its structure. Again, the first part ensures that the where clause always evaluates to true. And the union select one statement adds as many rows to the output as will be necessary. With that part done, the next part selects the table underscore name metadata from the information underscore schema.tables view. The where statement filters the metadata to only display regular tables, not views, inside the DVWA database. Click Submit to execute the injection. Notice that we get 2 rows added to the output, one for each data table found in the information underscore schema.tables view, the guestbook table, and the users table. We are interested in the users table. Step 7 is to retrieve the column names from the users table. To do this, we will query the column schema. Again, I will copy it from the lab. Let's take a look at what this does. This time, we want the column names. These come from the information underscore schema.columns view. We then filter the metadata for just the column names from the users table, a table name we discovered in the last step. Click Submit to execute the injection. All the columns are now listed. The user and password columns are the ones we are most interested in. Now that we have a good understanding of the structure of the users table in the DVWA database, it's time for Step 8, in which we retrieve the user's credentials. To do this, we enter an SQL injection that gets the user and password columns from the users table, as shown here. I copied the injection from Step 8 in the lab and pasted it into the user ID field. Click Submit to execute the injection. All the users and their encrypted passwords are now displayed. Step 9 is to crack the passwords. Although we are probably most interested in the password for admin, let's crack them all. Select and copy from the admin encrypted password to the end of the output. Open a new tab in the browser and go to crackstation.net. Paste in your clipboard and then delete everything but the password hashes. Answer the CAPTCHA if necessary and then click Crack Hashes. Now we have the passwords for every user in the users table for the DVWA database. Part 2 is to research methods to mitigate SQL injections. A simple search for SQL injection mitigation should yield some appropriate results. You should be able to find this cheat sheet from OWASP. Open this and read through the detailed explanation of SQL injections and the techniques you can recommend to your client to prevent these vulnerabilities. As you can see, SQL injections are a popular attack vector for threat actors. As a penetration tester, it is your responsibility to learn how to mitigate these types of attacks. Have fun as you continue to learn more about vulnerabilities you can exploit in penetration testing and how these vulnerabilities might be mitigated.